Hi. Now we're gonna focus more on the spatial temporal aspect of the biomechanical analyses, and there are two ways of extracting spatial temporal. So let's first go ahead and open up our spatial temporal pipeline again. Like I mentioned, I always recommend that you first do it yourself. So follow here, follow the video, do it yourself. And if you have any troubles, then go back to the pipelines that I made. It's always better to do that way to make sure you consolidate those memories and you practice it yourself, so you feel accomplished as well. All right. Again, if you first start with save as file save as. So here we'll focus on creating spatial temporal outcome measures, both manually and automatically. So there is a pipeline command made by Visual 3D to compute spatial temporal, and it's called metric compute temporal distance. So when you go to metric and filter, it'll give you metric compute temporal distance, and here create the temporal distance metric for gait. Now the problem with this specific method is that it only gives you the means and not really the individual spatial temporal outcome measure. For example, like, let's go ahead and run it, and then so you know what it means. So first of all, again, you can do it like a more user-friendly way when you double click on it, or you can go and do it from the text option. What you need to do here is, first of all, you can click on either calculate for each file, or calculate for all of them, and on whatever, but the best thing is to calculate for each file, and then you have to choose the location for the right foot segment. It usually understands these, so automatically like fills these for you, but if it doesn't, then you just direct it, so it's within the kinetic kinematic, if you remember from um, the first video in these 200 series. And the left foot, so same thing, proximal end position, whatever you want to choose, and then the height, which is saved in a metric processed height. So here we'll ask you to also choose the gait events that we created, and also in the first video, so the left heel strike, the left toe off, right heel strike, and right toe off. And here when it asks you to choose select temporal distance items to report, so anything that is highlighted is chosen. If you want to unclick it, then you just click on it and it will be unhighlighted. So I chose all of them, and then you create the results folder, so heel temporal distance, and then hit done. So when we step on this, so let me for example go back to this metric, because I've already created this, and let me delete this. And by the way, you can delete any folder, you can delete any data that you want, that you don't want to use anymore. Alright, so let's compute this, let's step it. So you see here there's no errors, no warnings, it gives you like the whole report. And now when you go to that folder of metric, so the metric is, the type is metric, and then the folder is called temporal distance, and then you'll see all of these outcome measures that were created. So for example, if we want to go to like the cycle time, or double limb support, let's go with one that is familiar. So let's say step length, left step length count, so it gives you like how many steps, so 3 steps, and it gives you the mean, which is 0.38 meters, but it doesn't give you like each of those steps and the value of each of those steps. Step time, same thing, so it gives you like the mean standard deviation and gives you the count, but doesn't really give you like the values of each one. So that's the downside of this. But if you don't care about that, for example, if you only care about the mean, then it is a helpful and fast way to extract spatial temporal measures. But if you want to do it the real actual way, then you have to um, get down to work and spend some time coding. Alright, so let's get started. I believe you can also find most of these online. When you go here, let's see if you can locate it quickly. Spatial temporal. Let's just skip the best references. Just let me quickly pause. Alright, so I found it. I found like the temporal distance calculations for gait. So if you just type this on CMotion, you'll find all the specifics about the command that Visual 3D uses. So as I just saw you, it's basically like everything that we went through, but it also talks about how you want, for example, if you want to report, have like a report chart, then you can also generate that and other stuff as well. You can also change the text in the temporal distance chart and so on. So it's useful. Temporal distance calculations for gait. I'll also provide this link for this specific tutorial. Alright, but if you want, like again, if you want to get specific values for each outcome measure, spatial temporal outcome measure, you need to do it manually. So to do it manually, first, to calculate the stride length. So basically from the left foot, from left heel strike to left heel strike, then we use this metric vector between events. And we're gonna use this to calculate both the stride length for left and right feet and the step length for both the left and right. So when we go to metric here, again, within the same metric type, I guess, if you want to call that, you can see metric vector between events right here. It's very useful if you want to get a specific distance or anything really you want. Like for example, I don't just use it to get these spatial temporals, but also when I want to measure like slip distance, then I use that between like start and slip stop. You can use it in any other thing you want really. Alright, so you choose that, and then we go here in the text. You need to do it like the text way or this way, wherever you prefer. In the text you see here, like calculate metric stride vector proximal position of the left foot from left heel strike to left heel strike. And then also we want to generate the mean and deviation. So you see here, like in our kinematic, we choose the proximal end position. You can choose anything. You can choose like the center of gravity of that foot. You can choose like like a specific marker, anything you really want. It's up to you, But I chose this, so we know like by the proximal end position, you can either like use this or the heel marker. It's really the same thing. And then we also we name it stride vector. You can specifically like exclude events if you want that, but then generate mean and standard deviation true. So we want that. If you don't want that, then you just unclick it. Alright, so we do that for we'll do the same thing for the right foot as well. And then in terms of the step length, so for example here we calculate the metric left step vector. So we use that between the right heel strike to the proximal position of the left heel at left heel strike. So we use the start signal of the proximal end position of the right foot, and then the end signal of the proximal end position of the left foot, and then we use the sequence of event from the right heel strike to the left heel strike. And then we name it left step. You can name it anything you want. And here we didn't generate standard deviations and means, but you can generate that. And then we do the same thing for the right foot, but then we flip it, so we do like we start on the left foot and then we end at the right foot, and then we start at the left heel strike to the right heel strike. Alright, in order to calculate the left step length, you can also use the metric dot product. So then we go, the metric dot product creates a dot product of two metric vectors, result metric 1 and metric 2. So here we calculate the left step length by taking the dot product of left step and stride vector mean. So the result metric name is left step length. The metric name is left step, the one that we just created. The metric name 2 is the stride vectors mean, the one that we also created here. So because we created the mean as well. So do that to extract the left step length, and then we do the same thing to extract the right step length as well. To calculate the right step width, we use metric cross product. So here it creates a product of two metric vectors. And here we chose the metric 1 as the right step and metric 2 as the stride vector mean. You can either do it this way, or also you can choose the vector between the right step and the left step, and then just choose the x value, which is the distance between the x, so this is the frontal distance between the right and left steps. But if you want to be more specific, I like to do it this way, because I don't believe it's just like the x value, but also it's basically the Pythagorean between the x and y to get the step width, and that's why we're doing it this way. So the cross product, calculate the right step. So calculate the right step width by taking the cross product of the right step vector and the stride vector's mean, and then generate the mean and standard deviation. So we start with the right step, and then we go to global stride vector mean, and then we give it the name of stride width, and then do the same thing for the left step width as well. And then if you're probably wondering like what's happening here, is once we get the right step width and the left step width, then we extract the step width for all the left steps, and then we extract the step width for all the right steps, and they never like interfere with each other, because it's right left. So you're just basically filling the gaps between both. and that's how we did it. Then you're probably wondering what is the global. So global, if you go here, if you go under here and then go to global, global basically has data that you can use from all other trials. So when we generate like temporal distance, it will be saved in global, so you can access it anytime you want, like regardless of what trial you're working on and so on, you know. Okay, so go back here. It doesn't matter because we're gonna run it for all of the trials. So okay, so after we create the right and left step widths, and then we are gonna start coding. So this is this is something I haven't talked about before, but this is a very, very powerful tool in Visual 3D. It's called Evaluate Expression. Evaluate Expression lets you code anything you want, um, like you're coding in MATLAB, but it's a little bit different than MATLAB. So they use like different annotations to run specific analyses and codes. So when you go and click here and just click like evaluate expression and then filter it, it's gonna be under signal math. Let me just actually remove everything, and then this is basically like the everything that Visual 3D offers. So if you go to signal math, you'll find a lot of different commands, you know. Evaluate expression here will tell you like evaluate an expression for signals across frames. No, signals should be placed into the expression in the form of signal type and then two two dots, and then the signal folder, and then the signal name. So this is what you always have to do before you run the expression. And this is what it will. This is what it looks like when you run the expression. So the expression itself is the code you're running, and then here the signal, the result type, the result folder, and the result name. This is what you need to write. So for this expression, you can either, so this is what I've also tried, right step length, left step length, by basically subtracting the proximal end of the right foot from the proximal end of the left foot. And the same thing for the right step length. So you can either do it, which basically, you know, gives you the vector between both feet. So you can either do it like by this way, so metric vector between events, or you can use an expression as well. And then once you have created this specific expression, you see here like metric value, metric signal element. If you remember from the previous video, we use this to extract the global maximum, so like the peaks of each joint angle or whatever, like used in terms of inverse kinematics, inverse dynamics, at those events that we created. So here what I used, the other method that I tried is, and all of these work by the way, and you'll see. So basically you create the vectors between the right foot and the left foot. So basically we do it this way. So you like the expression, basically you go and find the right foot for the proximal end position of the right foot. So you write the type, which is kinetic kinematic. Let me just actually move this here so you can see it. So when we go to kinetic kinematic, so we have all of these. So we go to validity expression. So we find the type, which is kinetic kinematic, and then we find the foot. Let me zoom in so you can see it actually here. Okay, so you type the type to the kinetic kinematic, and then two dots. You have to put two dots, two of them, and then you type the folder, which is right foot. You're working with the right foot, and then proximal end position. Then you do your calculation. So mine is again kinetic kinematic, left foot, proximal end position. So here we're subtracting the position of the proximal end position of the right foot minus the proximal end position of the left foot, and then we use that as the right step length. We do the same thing for the left foot, and then we extract the position. You can either do it like manually here, so we have the event is the right heel strike, so we're extracting the right step length at the right heel strike position, and we're using the y value, so like the distance, that distance at right heel strike. And then we do the same thing for the left heel as well, for the left step length as well. Alright, and then we calculate the stride length by adding the left step length to the right step length, because we do like right heel, left heel, so right heel strike, left heel strike, and then we calculate this distance as the left step length, and then from the left step to the right step we calculate this as the right step length. When we add those together, it's gonna be the like right, left, right, it's gonna be the right stride length. It's not as accurate as this method, because we know um, there's a difference between like step and step and just going straight directly to that, and that's what stride is, like from right heel strike to right heel strike. So you can try both, but I recommend this first method for both, the step length, step width, and stride length. All right, the next method are the temporal outcome measures. So we finished the spatial, so we extracted the step length, step width, and stride length. So in terms of the temporal outcome measures, we use metric time between events, which gives you, it's just self-explanatory. So it creates a metric from the time between events or between start and end of a sequence of events. So here we just basically choose the sequence of events from right heel strike to left heel strike, and then this is going to be the left step time, and then we choose left heel strike to right heel strike, it's going to be the right step time, and then calculate step time from right heel strike to left heel strike, um, and then the step time so it looks like this has been done twice. Append existence value. I don't know why there are two in here, but I probably okay, I understand. Okay, so we created like the left step time, as I mentioned, and the right step time, but then we also created the step time for both, like, right, it doesn't matter, for which foot. This will give you like basically the sum of both, not the sum, but all the data together from the left and the right steps. Alright, so then we start the left step stance, the stance time, which is from the left heel strike to left toe off. Then we do the same thing for the right stance time, and then the left swing time is from the left toe off to left heel strike, and the same thing for the right swing time, and then the left cycle time, and this is going to be like the stride time for both left and right. So it's from the right heel strike to right heel strike, from heel strike to heel strike, both for the right and left. Um, and then cycle time is gonna add like both the left and right together. So when you always append an existing value, so you don't add it to the first, but then you add it to the second, so it just adds data to it. It doesn't override it. That's why when you go here, you have to like append existing metric value so it doesn't override it. Or you can just go in the text and just type true. All right. And then here I've created this terminal thing. You can keep it, but I mean you can take it off, but it's useful to keep it. So calculate the right terminal double limb support from left heel strike to right toe off, exclude left toe off to right heel strike. So basically here we're calculating the double limb support time. So we're doing like left heel strike to right toe off. So the time where both feet are on the ground, or on the ground at all time. That's why we choose the left heel strike to the toe off, not the right heel strike. Then we're excluding the left toe off to right heel strike because that's technically the swing phase. All right. So you're just basically calculating the time of the gait cycle minus the swing phase. We end up with the double limb support. So we do that for the right and then for the left. And then we switch from because I believe it gives you the results in frames. Wait, let me double check. So here it says right heel strike to left toe off. So same left heel strike to right toe off. But here's from right heel strike to left toe off. Left initial doubling slips, right initial. So I'm a little bit confused in here. So let me see. Calculate left terminal double limb support from right heel strike to left toe off. Exclude right toe off to left heel strike. So we call this right heel strike to left toe off. So right heel strike to left toe off. Yeah, this will be the left terminal double limb support. and then we did the left, then we did the opposite. Left initial double limb support. Oh, okay, I understood. So the difference here is that one is the initial, the other one is terminal. Yeah, that's the only difference. But it's, it's up to you what you wanna use. Usually the double limb support is it's just this, so the terminal. So like when you go from left heel strike to right toe off, that's basically the double limb support um, time. Alright, so once we're done with that, then you select active files, you choose global, and then here we calculate the double limb support time by adding the right terminal. Yeah, this is what I was thinking about exactly. So we choose calculate the double limb support time by adding right terminal double limb slip support mean and the right initial double limb support time mean. Yeah, that makes sense because you want to add both of them together. The right and left support. So the initial and the yeah. So for the right, whatever like side, you add the initial to the terminal to make sure that both times within the same gait cycle they are included in that calculation. Because if you remember, here's the gait cycle. There are two phases where the foot is touching the ground. So we have double limb support, then single limb support, then double limb support too. So we have both. That's why we calculate both the initial um, and the terminal. Yeah, that's what I was a little bit confused. I'm like, yeah, what's going on? So yeah, once you do that, then you just add both the signals together. You can either choose this add signals, or you can choose like the evaluate expression. It's the same thing really. Uh, not the same outcome, but not the same command. But here, add signals, just add signals. And then we have double limb support. So we do that for that, and then we select active files. Okay, so here we just basically extracted the magnitude, which if you see the magnitude here is just like the Pythagorean, so you get the square root of all the x, y, and z coordinates to get the stride vectors magnitude. So the magnitude of stride vectors, and then from there we calculate the stride length by just extracting the mean. And we're done. So then we export the data to ASCII file. But I believe here I should have also double limb support time. I don't know why here there's only the right. So right, uh, calculate double limb support by adding the right terminal and right initial. Double limb support, double limb support. Oh yeah, it doesn't matter I guess if it's right or left. Um, they're both gonna be, so basically either like starting from the right or starting from the left is what you choose. Okay, so yeah, you can either go with the right or the left. It should be fine for both. Alright, then the last thing that I wanted to show you is how to export data. So I will also show you like in the next video how to export large set of data, but in this video I'll just show you how to export data the easy way. So you can either like double click on this and it will basically like ask you to browse wherever you want to export it. So let me just keep it on the same folder. And here you have to basically go to, if you want to do it manually it's a little bit more time consuming, but if you want to do that you basically go to, let's say like nothing is wait, let's say there's nothing, see like there's nothing clicked, so you browse, you choose your folder, then you go here, you want to choose your specific outcome measure that you want to export. So you go signal type, then you choose the type, whatever, like the metric, the one that we just did, for example, then process, then you choose the folder, so signal folder, and then you choose the signal name. Okay, so once you choose that, let's say left step width, then you can choose the components, so either like specific ones, or you can choose all of them. Just choose all, and then if you want to normalize it by step length, for example, or step or stride length, then you just choose here like the event sequence. So let's say this is the left step width, then you don't necessarily need to do this for spatial temporals, but for example if we choose like the actually not this link model based from the previous video. So if for example you want to extract um, the right knee angle, for example, here, and you want to extract the right knee angle but also extract it normalized by stride length. So just like choose right heel strike to right heel strike event sequence, and then you have to add, so add new signal, so then it will be added here. You see event sequence, then it will give you like the normalization, so it'll be like basically normalized by gait, and then you hit OK. If you want to do it like by hand, I believe it's much easier, less time consuming. So you go here to the signal type, then you write the signal type, you write the folder right below it, and then you write the actual name. And every time you want to add another signal, you do the same thing. If you remember, like from one of the videos before, so you just add the plus sign, and then another, and so on. And then here, when you go to the signal, the file name, then you write the file path, and then the last thing you just write the name of the signal type you want. So like you can like type v3d tutorial, and then spatial temporal, and then you write today's date, so 23 December 22, and then .txt, and we're good. So once we like execute the pipeline, it will do everything for us. So I don't want to save it. I'll save it later on. It did actually give us one error, so let's see what's the error. Processing aborted because folder, okay, I did not choose the actual thing. I did not change the path, I guess. Yeah, so let me go here, but it actually did process everything else. So just gonna actually go here. Off and like video tutorials. Alright, so this should be fine. So everything is already created before, so if we go here to metric and then processed, let's close the first one, processed. So now you see, for example, like if we hit, if you click on step time, so it gives you the all the step times. If you just want, for example, like left step length, then it gives you like all the step lengths. Because we have all files clicked here, if you just go to one of these motion files, it will give you like all the step lengths, you know, and everything else you need, like step by step, right step lengths. So you see, remember, because you created these right steps and left steps as a vector, it gives us x, y, and z coordinates. But then we create but then you only took the x, but not from here, from the and then also the means, right? The step times, step widths. So you see, it's much more useful than the automatic one that Visual 3D creates. So here, we go back to the export. So we have all of those. Then we step again, processing imported because folder. Um, there's Spatial Temporal there. I didn't see that. See, it's always good to double check. Because I'm just saving it here. Actually, like inside of here. So, alright. So let's step it. Should work fine. And then you see it here. So this is the. I automatically say open all of my TXT format files on Excel, but if you don't have that set up, it will open it in TXT format. So just notes, notepad. Alright, but then you'll see everything here. This is what I mentioned earlier. When you export it like this way, you'll first have the whole path of the whole name path of the file, and then right under that you'll have the actual name of the outcome measure, and then the outcome folder, and the outcome, I guess, the outcome type, and then the outcome folder, and then it will give you the coordinate in here as well. So you see here, because we also exported the right knee angle, so you see they're exported, you have like all the coordinates, so x, y, z. Then we have the right knee angle. Why did it export it 3 times? Right knee angle. Let's see here. It could be, for example, if I choose to if I choose to like plot this, you see, like from 0 to 140, from 0 to 140, and then from 0 to 50. So what they did here is that they exported like the right knee angles from right heel strike to right heel strike, but in different columns. Yep, that was it. You're probably wondering why is it like this. That's because it's not gait, it's a slip trial. That's why the right heel strike is not perfect. But if you have like just normal gauge, I don't know, like walking on a treadmill or walking on the ground, it should be fine. All right, so that's it for this tutorial, and the next tutorial will go deeper into how to use for loops and how to export using for loops if you have large data sets. Well, thank you for listening. Again, as always, if you have any questions, reach out to me. Thank you.